Good evening, I'm Christopher Ivan Molina Hinojosa, and today I'm going to be exposing my problem situation in statistics. So here are the contents that we are going to be seeing today. We might start with the part 1 of the problem that tells us that a used car dealer wants to predict the selling price of a Camaro brand car. 31 data were collected onto the sale prices of the cars, taking into account variables such as age, mileage, condition, and if the car had only one owner. Here we have the table with all the data that we will be using in this problem. So we might use regression models. So basically, our regression models tells us the relationship between the variables by fitting a line to the observed data. Here we have a picture, and to tell if a model is good or not, we might use the R squared. Basically, the R squared, the nearer to 100% is, the better the model is. We might as well consider what are the qualitative and quantitative variables. The quantitative variables are the ones that can be expressed in numbers, such as the age of a person, the results of throwing a dice, the salary of a person, works in a company, etc. And the qualitative variables, also known as categorical variables, are the type of variables that describes an attribute or characteristics of a data point that rather than a numerical value like the gender, the race, the religious affiliation, the educational level, etc. So here we have a graph that tells us the relationship between the age and the price of the car. The more the age of the car, the less the price is going to be. Here we have the p-value that tells us it is statistically significant, and the r squared that tells us it's a very good model because it has an r squared of 76.11%. We have the next graph that is the mileage and the price. Again, here we have the more the mileage of the car is, the less the price is gonna be. So here we have the p-value, as you can see, is pretty low, so it's statistically very significant, and the R squared is about 73.38%, which tells us is a good model to predict the price of the car. So here are all the equations of linear regression, but we may consider the multiple variables equations for the model. Finally, we have the qualitative variables. Here we have the condition. 0 represents poor condition, 1 average, and 2 excellent condition. The p-value is less than 0.05%, which tells us is very significant. It is a statistically significant. The R squared is 49.05%, so it is not a great approximation of the car's uh, price, but it might be as well one that you might consider. And finally, if the car had one owner, actually, I don't. I think that the zero represents the car had more than one owner, and the one represents that only had one owner because that's how binary works. But again, the R squared is 43.40%. So we may consider multiple linear regression models to see if any of these could tell us significant information about our data. Here we have the age and mileage. The price is equal to this number multiplied by the age and this number to the mileage. So the p-values of all these values are less than 0.05. So this is a very good model. All the variables are considered into the data, and the R squared is about 81.12%, which tells us is a very good relationship between the data. Here we have a model with all the variables. Here we have the p-values, but the one ordinary p-value can't be taken into account. If you see here, the mileage of the one owner goes up to 0.05, which it's statistically not as significant as the other p-value of the mileage. The R squared is 88.83%, which tells us it's a very good approximation with, but as well, the p-value is different. And finally, we have another that I consider the age, mileage, and condition values. So we have that it has an R squared of 57%, and all the p-values except for the mileage are less than 0.05%, which is statistically pretty significant. So if you ask me to choose one, I would choose the age and mileage. But if you might consider the qualitative variables, I would choose the age, mileage, and condition, because again the one owner p-value is pretty high, so it can't be taken as good. The part two of the problem is asking us to forecast, to predict what are gonna be the sales on the year four of the cars. So here we have the tables with the quarters. We might consider what is forecast. So basically, forecast is predict what the values are gonna be. Uh, Based on historical data as we have here. And there exist different types, time series, causal, machine learning, and ensemble models. We're going to be using only the time series and causal models. And the exactitude measures tells us if the model is a good approximation to the reality of if it isn't. So we might be using the MAPE as our first option because it is easy to understand and it tells us the absolute error size in the percentile terms. So all the error in the data. So we have here a time series graph of how the model is working. You can see here the H1, H2, H3, and all the quarters of this year. You can see that in general the model is growing. So in the next years, probably the sales are gonna be more than in the previous years. So we might consider that to our data. We start graphing different models to see which one fits the better to our data. Here we have a map of 43. This is a simple moving average with a length of 2, and the forecast isn't very good, so we can't take into account this model. We get another model of moving average with map of just 21. But again, for how many tab works, all the forecast is gonna be the same because it only takes into account the previous data, not the generated data that are the moving average. So this model, if the model, aunque tenga 21%, we can't use this model. We have the exponential smoothing model that has a map of 37%, uh, well, of 37, but again, we have the same problem as the moving average models, that all the forecast is the same because of how many tab works. So this isn't a great model again. And we have a trend analysis model that has a map of 29, a MAD of 2, and a MSD of 5. And the forecast is different, so this is great. But again, it's not taking into account all the seasonality, so this model could be better. So we might consider another models of data. Here we have Winter's method. Winter's method is a better exponential smoothing method and can predict seasonality. So here we prove a multiplicative method and additive method, and we vary all these constants of suavization to get the better model, the model with the lowest map. So here we have 0.248, it doesn't work. Here we have 0.332, okay, better. Uh, Here we have 0.524, the best of all. And here we have additive method, 0.258 worse, and 0.341 worse, and 0.431. So the best method is the Winters multiplicative method for which contains of 0.4, and the model is 41 cars. So which this forecast, you can see here the forecast. What are the conclusions? I have tell the conclusions for each part, but the quantitative regression model is the best according to me. But if you want to take qualitative data, you could consider the the state of the car. And the forecast model seems to be the Winters multiplicative method with parameters adjusted to zero point 0.4. This gives a mapping of 24.21 and predicts about 41 cars for the next year. Finally, here are the references for the work. And that's all for today's video. Thanks for watching. See you later.